In part 1 and 2 of this video series, we learned that reducing your emissions as much as possible, as well as farming in a way that will permanently capture carbon in the soil, is important to combat the negative effects of climate change. But it's also important to continue farming in a way that increases soil health and is good for our planet and produces healthy, nutrient-dense food. We also highlighted the importance of measurement to allow you to have accurate data to establish a baseline and show improvement over time. Remember, you can't manage what you don't measure. In part 3, we are sharing results from the work completed with the Maize Trust. Data from industry resources were used to model the amount of carbon emissions generated and the amount of carbon sequestered, as well as to determine a measurement of carbon stocks. 3 different farm management regimes were simulated, namely conventional agriculture, which involves full tillage and low organic matter inputs, conservation agriculture, which means minimum tillage and medium organic matter inputs, and future conservation agriculture, which entails no tillage and high organic matter inputs without manure. The latter is an ideal but realistic conservation agriculture system based on certain assumptions. We took a regional approach and covered 6 summer rainfall regions for carbon sequestration modeling and an additional 2 regions for carbon emissions modeling. So what have we learned in terms of carbon emissions? When we look at carbon emissions per ton maize, we can see that conventional agriculture systems are the most carbon intense compared to conservation agriculture and the future conservation agriculture management regimes. When we look at carbon emissions per hectare of maize, we can clearly see the benefits of practicing conservation agriculture with no tillage and high organic matter inputs. What factors make conventional systems so much more carbon intense? Synthetic fertilizer use contributes most to the overall carbon emissions, and if we dig a bit deeper, it is mostly synthetic nitrogen that has the highest carbon footprint. To reduce the overall emissions, we need to focus on management practices that reduce fertilizer use, such as synthetic nitrogen, lime use, and also fuel use. These management practices should also increase soil health and lead to a higher soil carbon sequestration rate. In all regions, the future conservation agriculture system led to the highest carbon sequestration. Farmers that implement a no-till system with high organic matter inputs will thus see the benefit of an increase in the average carbon stocks per hectare, as well as an increase in soil carbon sequestration. Systems that make more prominent use of cover cropping per rotation will also result in higher carbon stocks per hectare. Therefore, smallholder farming systems that use a no-till high organic input system that makes use of maize intercropping in summer followed by relayed intercropping with winter crops and reduced residue removal will result in the highest carbon stocks and high carbon sequestration potential for smallholders. We also compared the soil organic carbon content of the different management regimes in each region with the soil organic carbon in natural veld. In all cases, the natural soil organic carbon exceeded that of the managed agricultural land and is indicative of the amount of carbon that could potentially be sequestered over time. This graph displays carbon emissions above the zero line and the carbon sequestration potential below the zero line. The sequestration potential calculated was significantly less than the annual emissions of producing maize for all regions, except smallholders. A first step would thus be to focus on carbon emission reductions at farm level and start building the farm's sequestration potential. In many instances, this is a parallel process as practices that reduce carbon emissions also build the sequestration capability of the farm. Conservation agriculture implemented as a no-till system with high organic inputs and reduced use of synthetic nitrogen will lead to reduced carbon emissions and an increased carbon sequestration potential. You will realize these benefits in addition to all of the other benefits conservation agriculture could have for you, such as that it has a positive impact on biodiversity, soil health and water. It leads to the effective management of weeds, pests and diseases, as well as improved food quality, higher and more stable production and profitability, higher carbon sequestration rates, higher resource use efficiency, and ultimately, conservation agriculture will help you mitigate and adapt to climate change. Conservation agriculture is also directly linked to soil health, which in turn is linked to the total health of our food system. Soil health affects everything from plant health to human well-being to the future of our planet.